Hello and welcome, YouTube. So this video is actually kind of a tribute to my kid brother. He had a very interesting problem that he posed to me, and I just couldn't help myself. I wanted to go through this and figure this out and help him. So here's the task. He and my father are currently out in Pasco, Washington. They're building an octagon made out of 2x4s. Now my father was kind enough to go and check out the lumber that he had, and he was able to give me some very specific measurements for the 2x4s that he's dealing with. Although they weren't necessary, I went ahead and plugged all that information in, and I drew a little 3D model here in AutoCAD. And this is AutoCAD Mechanical, Electrical, Plumbing, and Piping 2016. It's AutoCAD MEP 2016. And I'm going to show you kind of the problem here. So my brother said he wants an octagon built out of 2x4s. Now there was specific criteria. The criteria said it had to be exactly 26 inches from the face to the face on the inside. So let's go ahead and take a look at that. Let me make one quick change to this so we can see, in fact, that it is the 26-inch measurement that he needed. So let's modify this. And let's go look at that as fractional. Okay. So 26 inches, that's the criteria that he had. So what he needs to figure out is how long does he make each one of these, and at what angle does he cut them? So, oh, I made a mistake there. Let's go ahead and move that. And let's see. So what I'm using here with this drafting precision program gives me the information that I'm looking for. So right off the bat, I drew it. I was able to very easily sketch this out and give me the right sizes. And from there, I can just measure what those sizes are supposed to be. However, if you don't have AutoCAD, how do you go through about calculating what this size is? And I'm going to tell you a little story about Indian Chief SOH CAH TOA and how I use Indian Chief SOH CAH TOA and the mnemonic device that he represents for trigonometry. And it's very effective, and it calculates to perfection what these lengths are supposed to be. So in order for us to work with trigonometry, I just want to draw a couple of lines here. Trigonometry is the art of dealing with right triangles. Now, if you're not familiar with what a right triangle is, that's simply a triangle that has a 90-degree end to it. So I'm just going to draw a triangle here, and it has a 90-degree end. And let's go ahead and verify that that is 90 degrees. From here to here, yes, indeed, that's 90 degrees, right? So great. Let's go ahead and deal with this. Now let's move this off to the side, and let's go deal with the triangle off to the side, and we'll come back to this shape here in a little bit. But let's do the math with this. So we're dealing with an octagon. That means 8. So if you divide 360 by 8, that will give you the angle of how many angles that we're dealing with. So easily stated, I know that these angles are about 45 degrees each just by doing the math. 360 divided by 8. So let's go ahead and bring my calculator up and verify that. All right, so let's go ahead and do the math. 360 divided by 8 is 45 degrees. Now, that's assuming that I didn't cut one of these triangles in half to make a right triangle, right? So what I did here is I cut one of these triangles in half, which means that if I cut that 45-degree angle by half, that would give me 22.5 degrees. So let's verify that really quickly on my calculator. So let's divide that by 2. You can see that it is in fact 22.5 degrees. So what we have here then, let me go ahead and kind of sketch this out for you. It's 22.5 degrees, and I want to set my precision up so it's a little higher than what you see here. Now under the primary units here in AutoCAD, I can see I got decimal degrees, but the precision is set to 0. And really what I want is I really want three decimal places. So I have a total of 3 significant digits here. And let's go ahead and close that up. So we can in fact see that that's 22.5 degrees. let me label this as angle theta. So I'm going to put in a symbol. I'll go to so I'll go to the other symbols, and I'm looking at my Greek C 450, and here's theta. I'm just going to label it theta, and let's go ahead and close that. And that's it. So let me move that right into position here. So that's angle theta. And we know that to be 22.5 degrees. Now the other thing that we know is we know that the measurement from face to face is 26 inches. So the measurement then from the face to the center ought to be 13 inches. And it is. So I know that this length here is 13 inches. Let me just go ahead and pull that out. Now relative to the angle that I'm dealing with, this 13 inches is what's referred to as the adjacent leg. We also have an opposite leg that you see over here, opposite of the angle, and then we have the hypotenuse, which is the diagonal portion of this. So I'm going to label that as well. Let's go ahead and label that here as adjacent, and then let's label again right here as opposite. Okay, so if I take a dimension here, I will see that I've got 3 5/8, which is what I was expecting. But really what I want to do is, what if I don't have an AutoCAD program, right? So I need to figure out what this dimension is. So I'm going to call that X. I'm going to figure out using trigonometry what that is. All right, so now that we have all the variables set up, I've got my angle theta, I've got my adjacent, I've got my hypotenuse, my opposite, and I've also got my hypotenuse here. Let's go ahead and put my hypotenuse, HYP. Now, I don't know what my hypotenuse is. Of course, I haven't done anything to measure that or anything like that, and I'm not particularly interested in that. What I want is, I want X. I want to figure out what that length is. All right, so how do we figure this out with trigonometry? Let me tell you a story about Chief SOH. So, Chief SOH, let me show you how you spell it. It's very important to figure out how you spell it. SOH CAH TOA. There's spaces between each syllable here. SOH CAH TOA. So what that refers to, get this. This is so cool. So, okay, let's do this. So equals sine of angle theta equals opposite over hypotenuse. Okay? So you're looking at S equals sine of theta, and then you're looking at O equals opposite, and then H is hypotenuse. So that's the formula. That's how you're going to remember this. Let's do CAH. So that is simply cosine of angle theta equals the adjacent, oops, I did a D there. It's supposed to be a D. Adjacent, I put a P, over the hypotenuse. Okay? So that's CAH. And then TOA, this is the tangent of angle theta equals the opposite over the adjacent. There, I did it right that time, adjacent. So what you want to do is you want to take a look at SOH and figure out if that's going to work with this setup of how we've drawn out this this triangle, this right triangle. So when I look at that, I don't have the hypotenuse, okay, and I'm not looking for I'm looking for the opposite. So this is the one I want, but I don't have hypotenuse. So this one's not going to work for me. Now, let's take a look at CA. So I know the angle, right? So I know this angle, and I know this angle. But not having this hypotenuse disqualifies me from using this. So I can't use so. So let's take a look at CA. So I know the cosine, I know the angle. What I'm looking for is the opposite. So I do have the adjacent. I have both of these, but again, I don't have the hypotenuse. So that's not going to work. So I need to use probably TOA. Let's take a look if TOA works. So tangent of the angle, I know what the angle is, so that's my first check. The opposite, that's what I'm looking for, so let's put a check mark next to that. And then I also know the adjacent, right? So I know the adjacent, I know the angle, and I'm looking for the opposite. So this formula is going to work. So let's see how this works. I'm going to write the formula here right next to where all this is. So let's do this. Control 2. So I'm going to use the tangent. Okay, so this is what this looks like. The tangent of angle theta equals x, right, TOA, so that's O is on top, so that means x is on top, divided by, so TOA, the last letter is A, so that's the adjacent, so that's 13. Now, in order for me to get x isolated, I have to multiply both sides by 13. Okay, so that means 13 here, and then this would also be multiplied by 13. All right, so x, just rewriting this, 13 times the tangent of the angle 22.5 equals x. All right, let's do the math. Let's figure this out. So let me bring up my calculator. All right, so let's just start all over. 22.5, and I'm using a scientific calculator that brings up my tangent, my cosine, and my sine. So let's do 22.5. Let's do the tangent of that. That results in this funky number. And then let's multiply that by 13. So that equals 5.38477,631 blah, 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 blah. So it's 5.3 is what the number is. Okay? So let's do this. Let's do this. I want to get rid of that number. I overwrote it, and I put an X in there. Text override. Let's just remove that override, and it'll bring back my number here. So what you're seeing here is the measurement that I'm taking. However, it's not exactly that long digit. So let me change my style here to see if I can get that number. Let's override that digit. Excuse me, I don't want to override it. I want to modify it. Now, decimal degrees, let's do fractional. Let's do decimal for my units, and let's bring it out to like 5 decimal places. That's fine. So what you're going to see is that that number is exactly the same number that was calculated. It's just rounded up to 5 digits. So let's bring that up. Here's my calculator. 5.3, blah, 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 is the same number that I'm measuring here, right? So that's exactly the same number. So now that's the right triangle. Now remember that this right triangle is half of the distance here. So if I multiply this by 2, what you're going to see is that that number is 10.76955 exactly. Now again, I'm only going to 5 digits here on my precision, but when I double check that, oh, oops, I want to get my calculator Did I close it? I did close it. When I double check that number and I do the math, you'll see that it is exactly the same number. All right, so it's 5.38478 times 2 equals, and you'll see that it is the exact same number, just rounded up to 5 digits. So, in conclusion, Chief SOH CAH TOA is going to pull you out of all kinds of mess because you will always have some unknown variable in a right triangle. You're going to know an angle, you're going to know a length. That's all you need. You need to know one angle and you need to know one length. Or you could know two of the lengths and you could figure out the angle. So totally depending on what you have, you're always going to have two knowns and you're always going to be searching for the other. So you're going to use SOH CAH TOA in a way that's going to help you figure out what that is. Just remember the relationship. Let's get rid of these numbers here because that's not really the point. The point is Chief SOH CAH TOA. So just remember the relationship is always the angle and then what's opposite to that, right? So if this angle that I was looking for, maybe the angle was supposed to be over here, well, that changes the arrangement here. So that makes this guy, this other leg, that makes that one opposite, and it makes this guy the adjacent, right? So just remember the relationship. The hypotenuse is always going to be the hypotenuse. The 90-degree angle is always going to be the 90-degree angle. So if I'm searching for the opposite, I've got a couple of options to do that. I've got SOH and I've got TOA. If I'm looking for the adjacent, I've got a couple of options for that. I've got CAH and I've got TOA. If I'm looking for the angle, then as long as I've got a hypotenuse and opposite, then that's SOH. If I'm looking for the hypotenuse and I've got the hypotenuse, if I'm looking for the theta, I've got the hypotenuse and the adjacent, that's CAH, right? So cosine of angle theta equals the adjacent over the hypotenuse. So that's a wrap, guys. That's Chief SOH CAH TOA. That's trigonometry and how you go about figuring angles and getting the mathematics done if in case you don't have a precision drawing tool like AutoCAD or something like that.